All right, how's it going, y'all? Today, we're going over how to hook up two UniFi firewalls, and really this will work on any firewall, directly together. So this way, you can have two totally separate networks with separate internet connections on two different routers, but they're able to access resources across each other without having to go through the internet. This is something that ends up being really useful for things like offices, where maybe you have two buildings across the street from each other. They both have their own internet connections, but you want them to be able to have a very fast direct connection between each other. You can then use something like a microwave antenna to directly site to site them. So that way you've got the ability for that local network traffic to not have to go over the internet. I've set this up for clients before for a whole lot of reasons. One time there were two schools, an elementary school and a middle school next to each other. They both had fairly slow internet connection, so they just wanted their own dedicated internet. But they have common resources for servers, and so we set up where basically there was a 10 gig fiber line that was run in between the two of them, and that way anything that were going through file servers was not bogging down that internet connection. And really there are a ton of other applications for this. This is actually how really large, like campus-wide networks work. Albeit they do have much more automated protocols such as like BGP or OSPF, but really the technology underneath is the exact same thing. What we're setting up here is essentially going to be a direct connection between these two routers. We are then going to tell the machines, hey, if you're trying to talk to something on the other router, go through this cable. That way, they're two independent connections. You don't have to worry about bogging down each other's internet connections. Any server resources you're connecting to on the other router does not have to go through the internet. You could set up a site-to-site VPN between the two of them. However, now you're bogging down your internet speed. Instead, this is a really easy way to directly hook them up. And as I said, I've done this on other routers. It's really easy. All it requires is a cable in between them, a little bit of knowledge about networking, and a static route to just tell the routers how to route everything. Okay, so these are my two routers that we're using here. On the bottom, we have an awesome cloud gateway fiber. This thing's actually awesome. I've been meaning to do a review of it. I've just not had the time. And on the top, we have a cloud gateway max. And essentially this cloud gateway fiber on the bottom here has a Synology hooked up to it on this port right here. And the way I've got these set up right now is they both have different internet connections. Really, the internet is just my local network. But for the sake of this video, these are two separate internet connections, and maybe they're slow. Maybe they're 100 megabit. And you also just have a lot of increased latency. So what we want to do is we want to have anybody who is on this Cloud Gateway Max up here be able to have an easy, direct, fast connection to this Cloud Gateway fiber. But other than that, we want them totally separate. We don't want them mixing internet connections or anything like that. And overall, this is really easy to set up. As I said, you can do this on pretty much any two routers that are at least advanced enough to do a static route and different interfaces. But you do need one thing. You need to make sure that there are no overlapping subnets. If the server you are trying to access is on 192.168.1 and your main LAN is also on 192.168.1, you're not going to be able to do this. So you can't have any overlapping subnets, as you're just not going to be able to route traffic there. And ideally, you also have them split out into totally separate /16s for all of the VLANs in there. I'm going to show that in a minute here when I actually pull them up. But if you've ever followed one of my guides for setting up networks, the way I always set up office networks, home networks, any kind of network, is I pick a random 10 dot. 10 dot, I think in this case it's 140 and 120. And I assign every single one of my VLANs to that kind of subnet. That way, one, I know as I'm adding more sites, so maybe you've got 30 sites eventually and you want them all connected, you know they're not going to have any overlaps. And it also just makes it really easy to kind of tell where the network traffic is coming from. Finally, it makes this process super easy because we only have to write one rule, no matter how many VLANs we have. If we had a bunch of scattered ones, and I'll show that all here, we would just have to write a whole bunch of rules. All right, so that's basically the overview. And now we're just gonna pull this guy on up and we can just see the overall networks. So this first one is how our gateway max is set up. And we can see we've got a few different VLANs right here, and they are all on this 10.120, as I said. Then on our fiber, which is the bottom one, we do not have as many, but we do have that server VLAN, and that is where my Synology is hooked up to. and all of them are on 10.140. So what we're trying to do is we're trying to make sure that either machine is able to access whatever routes we want it to. And so what we're setting up is we want to make sure that we can just route that traffic in between them. And connecting them is as easy as a single, just standard RJ45 cable. You even could have it in its own separate VLAN if you wanted to, but for best performance and ease of use, definitely add it to its own. But what we do need to do is we need to set up a VLAN on each of them. And it doesn't actually have to be a VLAN, that's just how it is called in UniFi. If you're doing this on something like a pfSense box, you could actually just have it as its own network interface. That's all we need it for. But basically, we need a network that exists between these two routers that neither one of them is really in charge of, for lack of a better term. That's because this is going to be a network that they use to just directly talk to each other. And this is actually a great way, in my opinion, of learning how networking actually works. So, as I said, we've got basically two main large /16s in use here. 10.140 for our bottom one and 10.120 for our top one. Let's go ahead and we basically want to just have a network that only has two devices on it, and we're going to have that exist that only is between these two. So what I'm going to do is I'm going to create a virtual network, disabling IP6, and we're going to call it cross connect. So for this, we need to make sure that it's outside of any other networks. And the only two devices that are going to be on here are going to be the two routers. And neither one of them is actually going to be the router for it, though they both think they're going to be. What we're going to do is we're going to pick a completely random subnet that does not have any overlap with anything else. I tend to use the 10.250 subnet for this kind of stuff. Really, it doesn't actually matter. For sake of just ease of use here, I'm going to use 10.250.1 as our subnet. And to kind of designate the fact that neither one of these is truly the router, just helps people later on kind of understand what's going on maybe. I'm not going to set either one of them to being .1. There's no actual networking reason for this other than just it's a flag that somebody might see later on. And for our subnet mask, we really could make this like a /29, but for sake of just ease of use, we're going to keep it as a /24, just because once you start getting into random subnet links, stuff gets a little bit more confusing if you're not super aware of how subnets work. So we're just going to make it a /24 to keep it consistent for this tutorial, but obviously, if you know how these things work, you could easily make this a /30, I think. And what we're going to do is we're going to make sure that the VLAN ID does not overlap between either one of the units. We also want to make sure that we disable DHCP, and you can optionally choose whether or not to have multicast DNS existing on both of them. The reason we're disabling DHCP is we don't want both of these things trying to hand out addresses. They wouldn't be able to hand them out to anything, but by disabling DHCP, we don't get the warning that they're both detecting each other. Then we will be creating its own router zone for this later on, so we don't need to do anything like that right now. But now we are set up with this cross connect, and we're just going to go ahead and add it. And then we're going to come in over here. We're going to create the exact same VLAN on this one. But we're going to make the IP address different. So one of them is .3, the other one of them is .2. VLAN ID does not have to be the same or different, does not matter. And once again, we will be disabling DHCP. So now we have two virtual networks. And so let's pick two ports on these things and assign them. So what we're going to come in here and do is on our gateway max, we are going to pick one of our ports. I'm going to go ahead and pick port 4 actually. We're going to call it cross connect. Cross connect, and maybe just say what it is. Block all other ports and only allow that cross connect VLAN there. This way you make sure that there's no weird stuff ever going on where you've got two DHCP servers. And another thing that's probably good to do is especially if you're using a larger and larger setup, is block this VLAN from any downstream ports. You don't want any other switches accidentally pulling this. It'll just cause weird issues. But you want only this to exist on this VLAN. And I'm going to go ahead and do the exact same thing here. And I'm also going to set the same thing to port 4. doing the exact same thing. So now when I actually go in and hook up port 4 to port 4 on the two different routers, these two are going to have a common VLAN between them, a common subnet that does not have any overlapping, and essentially they now can use this IP address on that subnet to talk to each other. And that is the really key part about this. With networking, you need a way for two devices to talk to each other. You need a common subnet. And that common subnet is this 10.250.1 subnet. So now I'm just going to hook up port 4 to port 4. And now to go ahead and kind of test this out and make sure it works, is from our demo gateway max, we should be able to ping our demo gateway fiber. So I'm going to come in and turn on a thing called debug tools, which is very useful that they've added. And now I can actually just run a simple ping. So I am on the gateway max, which should be .3. Yeah, so the demo gateway max is .3 and the gateway fiber is .2. So I should be able to, from the gateway max, ping .2. And just like that, I now know that these two routers can talk to each other. Quite useless right now, doesn't do anything, but they at least now know how to talk to each other. I know that I can ping from the gateway max to the gateway fiber. Now all we have to do is tell these things, hey, if you want to talk to that other subnet, talk to this guy. And that's how this all works. All we've got to do is now create a static route. A static route is basically hard coding in a route to a router. Hey, anytime you need to talk to these things, go here. Basically, you're just manually telling it how to talk to different things. It's useful probably if you've ever set up a VPN server on Synology and want to do reverse routing. But here, we're just going to tell it, hey, Gateway Max, if you're trying to talk to anything over on this 10.140 network, try going to 10.250.1.2. So we're just going to do that. I'm going to come into the demo gateway max, and I am going to go into the policy table and create a new policy and just click new route. So you could also make this policy based. So if you're using something like BGP, there's really cool ways where you can actually have these routes dynamically propagate to a bunch of stuff. Really cool. And that's how large campus networks work, like enterprise networks. But here, we're just hard coding it because we've only got two of them. It's not that hard. We can add a third without too much trouble. So what we're going to do is we're going to create a new route. So this is basically just telling the demo gateway max how to talk to the demo gateway fiber subnets. And we're just going to tell it what the next hop is. And that next hop is the same thing we pinged, 10.250.1.2. And now the destination, who are we able to talk to over there? Over there, we are able to talk to everything that is in this subnet. We can talk to anything that is at 10.140/16. So as I said earlier, we can kind of shortcut this whole process by doing this because every single one of my VLANs that I want to talk to on the demo gateway fiber is all within 10.140. I don't have to write this rule for every single one of my VLANs. Instead, I write it once for the entire /16. And this is why it's really useful to kind of assign routers entire kind of /16s to work with. So that way, whenever you're addressing it later on, you just do it once instead of doing it 8 times. And now I'm going to do the exact same thing, but in reverse. I'm now going to say on the demo gateway fiber, we can go ahead and do the exact same thing. But now when the demo gateway fiber is trying to talk to the demo gateway max, it has to use that 10.150.1.3 IP address. And it is able to talk to the 10.120 subnet, I believe. Yep, it is able to talk to anything on 10.120.0.0/16. All right, so we've not touched any firewall rules in between them. Let's just see what happens and if we're able to get to that Synology. All right, so now I've directly hooked up to my Cloud Gateway Max, and you can see right here that we are on that 10.120.1.33 network. And we can also see on our fiber, which is the bottom one, we have a Synology hooked up there at 10.140.50.87. And just like that, I am able to route between them. That is how easy this is. Because they have that interface, they're now able to directly talk. And just to show that that's how they're talking and not any other black magic, if I unplug that interface and refresh the page, it doesn't go very well. Now we can also try out and just see kind of how much throughput we get out of this thing. All right, so I'm just going to connect to that SMB share, and I'm just going to pull a random recording, and let's just see how fast this thing goes. We are crossing over VLANs, so there is going to be some overhead to this, but both of these things are decently fast. And we are able to saturate that 2.5 gigabit connection hooking up between them, which is actually quite impressive because we are going through 2 different routers on there. And so they're able to fully route at those speeds. So you can see just like that, we're able to get really, really, really fast networking in between these two. If you had even faster units, you very easily do 10 gig. So that is how we're set up. Essentially, it is using that 10.250.1 subnet as a middleman. It is how these 2 routers are able to talk to each other and understand each other by having that little extra common point of communication. The static route then just tells them, hey, if you're trying to access stuff on the other router, you can get to it by talking to that 10.250.1 little IP address subnet that's in between them. That's how they know how to talk to each other. So now the last thing we actually have to do is actually set up some firewall rules. Because right now they are on the same zone. We now have to say exactly what we do and do not want to come crossing through that traffic. And we're going to use the zone-based rules over here, and I'm not going to go over it too in depth, but I do at least want to give the overall gist of it. So I left this on the internal zone, which made this very easy. We probably want to create its own cross-connect zone because it's such a specific thing. Depending on how you like to do this, you could also keep it internal, depending on what things we're going to cross there. But the easiest thing to do is to create a new zone just for this, because it's its own weird thing. And now we're going to use this to tell us exactly what we do and do not want to be able to cross across here. And because it doesn't actually know about all the VLANs that are on the other side, we have to be very specific and tell it. So this cross-connect zone is actually all the traffic that is coming from the entirety of the demo gateway max. That's the confusing part about this. Even though it only sees it as this one network, really we have to go in and we have to basically say, hey, anything in this cross-connect zone is certainly coming from the gateway max. And we need to allow only specific things. So for example, there's a guest network on the gateway max that we probably don't want to come over here. And you can see when I add that firewall rule, we got a disconnect because it started blocking it. So what we can do is write a rule depending on what we want to do. We're going to start with our source zone. And what we want to do is we want to say, hey, the cross-connect zone, we can't use the actual network because we don't actually know about the network. Instead, we create a subnet. So we are going to say, in that default network, that's the one we're going to allow through. You can repeat this for as many things as you'd like, but we'll just start with that. 10.120.1/24. And you could also use lists now. They've made this a lot easier. And we are going to allow that to come through. We're going to allow that traffic across, and we're going to auto return it. And then what we can also do, depending on obviously your security posture and how you want to set everything up, we're going to say that anything on the internal network can talk to the other network. We're basically going to say, hey, if you want to do blocking, do it on your end. We're trusting everything in the internal network. So essentially we'll say, hey, we're not going to do any of the blocking on this side. We'll let anything on through. And now I should be able to reset up that connection and it should go through. Then we would have to go in and obviously create the exact same mirrored firewall rules on the other system. And you can get as granular or as not granular as you want here. In general, I tend to recommend that you do your blocking on the incoming traffic. So instead of you saying, my users should not be able to talk to their stuff, they should be saying, their users should not be able to talk to my stuff. But it really comes down to the exact situation you're in. And you just write whatever firewalls you want there. The most confusing part about it is, unlike the rest of the zone-based firewall rule, you can't just use the network tab because the network is not actually the subnet you're thinking of. Really, you have to specify the exact IP addresses you want to be able to talk to. And that's going to be it for this tutorial. If you have any other questions, put those down in the comments below. And if you want to hire me, there's a link for that down in the description below. And have a good one. Bye.